Welcome to Chapter 1. In this chapter, we are going to focus on problem-solving strategies. We're going to look at a lot of different types of word problems, which, I'll be honest, may not be your favorite part of mathematics. You may not have the best memories of solving word problems, but they are crucial for students' understanding. When we grow up and get different jobs. Most people are not like me. Most people are not math instructors. Most people are not going to be given an equation to solve. You're not going to be given a quadratic equation and be asked to factor it in order to get a job. But everybody is going to be solving word problems, even if they don't look like your typical word problem from a math book. So problem-solving skills are crucial, and that's why we're going to start there. This first section is pretty short. I'm just going to go through 4 examples with you that are going to cover the 4 basic problem-solving strategies. But before we get into that, I wanted to point out that from time to time in the notes, you'll see I'll have these NCTM principles and standards. So the National Council of Teachers of Mathematics. For years, they've been putting out the standards, and I'll highlight several of them throughout the notes. So you'll always recognize them because they'll have the green border. I will not be reading through these in my video lectures, but I just want to let you know they're there for you to read through at your leisure. I want to get into the notes proper here. And like I mentioned before, sorry if you saw something weird on the screen. Like I mentioned before, there's 4 basic strategies when we approach a word problem. Good old guess and check, and we'll look at that in just a moment here, actually. A lot of times making a table, or even the last one, drawing a picture, can help. Also looking for patterns. The thing of it is that a lot of times you're not just going to use one of these strategies. A lot of times you're going to use them in conjunction with one another. And you'll see that here in just a moment. This first example will actually be making a table, using guess and check, and looking for a pattern all within the same problem. I also want to point out, as I go through these examples here, the way that I'm approaching these problems are not the only way to approach the problems. You might come up with a different method or a different approach to solve these. Your solution is equally valid, equally correct. Our brains all work differently, so we're not going to come at them with the exact same approaches. But I just want to give you insight into one method for solving these. So this first one, we're told that the spring concert at Port Angeles High School sold 145 tickets. Students were charged $3 each, adults $5 each. The income from the sale of the tickets was $601. How many students and how many adults bought tickets? So like I said, there's multiple ways to approach it, but what I'm going to do is I'm going to start by making a table. So I'm going to do several columns in this table. I'm going to have one column for the number of student tickets that were sold. And then I'm going to have a second column with the number of adult tickets. Then I'll look at how much money was raised from the student tickets, and I'll do the same for the adult tickets. Sorry, my K is a little wonky there. Oops. And then the last column is going to be the total money raised. And obviously, the total money we want to equal $601. So here is my table. And I'm going to start by doing a little guessing and checking. It says that 145 tickets were sold. I'm going to make a guess here. I'm going to break that down as 100 student tickets and 45 adult tickets. So the guess was 100 student tickets because there's 145 tickets total. There has to be 45 adult tickets. So how much money did that make? Well, the student tickets are $3 each. 3 times 100 is going to be $300. The adult tickets are $5 each. 5 times 45 is $225. So the total money raised in this case, if you add these together, is going to be $525. That is too low. It says the total income was $601. So we need to guess again. So to make more money, I need to sell more adult tickets because the adult tickets were more expensive. So I need to adjust my numbers a little bit. I'm going to guess for my second one, 80 student tickets. And if there's 80 student tickets, that means there are 65 adult tickets. Because 80 plus 65 is 145. So same process. 80 times 3 is going to be $240. 65 times 5 is going to be $325. And if we add these together, we're at $565. So we're getting closer to that 601, but we're not quite there. So I mentioned a couple minutes ago, we're using multiple of these strategies. So I've made a table, I've done a little guessing and checking, and I'm looking at a pattern here. So I'm getting closer, so what I need to do is I need to do even less student tickets. So I'm going to check 60. 60 student tickets would mean 85 adult tickets were sold. So we're going to repeat the process. 60 times 3 is 180. 85 times 5 is $425. And 180 plus 425 is going to equal 605. So we are really close here to that goal of $601. We're actually a little bit too high now, so I need to ever so slightly adjust my numbers, but I'm really, really close. I just need this to go down by $4. And to do that, we're going to bump the student tickets to 62. That leaves 83 for the adult tickets. At $3 each, that's going to give us $186 for the student tickets. Adult tickets are $5 each. That's going to be $415 for the adult tickets. And if you add 186 and 415, there's your $601. So how many students and how many adults bought tickets? There were 62 students and 83 adults that bought tickets for this spring concert. So there you can see multiple approaches to solving a problem all within this same solution. Like I said, you don't have to solve problems the exact same way that I did. This is just one approach for this one. As long as you get that answer, 62 students, 83 adults, and you're not making any sort of mathematical leaps that are impossible to make, you have a valid approach. I'm going to do one more example on this video, then I'll do a second video to finish up these notes. So on the second page, it says, who am I? If you multiply me by -2 and then add 12, the result is -4. Once again, you've got multiple ways that you could approach this. What comes to my mind at first is either doing a guess and check or and would depend on your skill. If you were teaching this, it would be the skill of your students. This could be solved algebraically as well. With guessing and testing, you literally would just guess a number and then go through the procedure. So let me give you a for instance. Who am I? Maybe you're the number 10. So if you multiply me by -2, 10 times -2 would be -20, and add 12, the result should be -4. This gives you -8, so you would need to check another number. So you could go through that process for guess and check, and it would give you the correct answer. By the way, the correct answer is going to be 8. But if you are more algebraically minded, let me switch to a different color here. If you're more algebraically minded, you could set up an equation. I'm going to let the number be n. So I'm going to let n equal the number. If you multiply me by -2, so that would be -2 times the number, and add 12, the result is -4. It equals -4. So you could just solve this equation. It just takes a couple steps. Subtract 12 from both sides. So you have -2n now equals -16. Divide both sides by -2, and n is equal to 8. So you could go through guess and check. If you had younger students that hadn't learned any sort of algebra or any form of algebra, guess and check is going to work. It doesn't take that many guesses for most people to get the answer here. But algebraically, it's just a two-step equation. So again, multiple approaches, but you will get the same answer either way.